process. Biomass storage and drying. Wooden or agricultural biomass stored in a dedicated storage facility is transported to the pyrolysis reactor via a bucket feeder.
This is show that how the biomass is stored.
The raw biomass is pre-dried inside the feeder through the use of hot and dry air flowing in the cross-flow.
Next, this is the bucket feeder that going bring the biomass into the pyrolysis reactor.
Biomass pre-drying has a positive impact on the reduction of the moisture content inside the process material by a few percent, and additionally increases the pace of the processes occurring in the following stages. Biochar production. Pre-dried and preheated.
Next, in the pyrolysis reactor, is going to be produced the biochar.
Biomass then goes to the pyrolysis reactor, where the following four processes take place. The moisture evaporation process. All the moisture accumulated in the raw biomass has to evaporate in order to initiate the carbonization process. Depending on the type of biomass and the amount of moisture accumulated in the process material, it can take from several to more than a dozen seconds, and its efficiency is due to the high temperature in the upper part of the reactor. The degasification process. In the next stage, the biomass is degasified in the temperature range of 370 to 400 degrees centigrade, within which range the removal of volatile particles is most efficient.
Next is the gasification process.
Chemical compounds like nitrogen, carbon monoxide, carbon dioxide, hydrogen and others are flammable, and approximately 40% of the energy yield is consumed by the pyrolysis process. After mixing with the humid air from the preceding process, the remainder of those gases can be used for energy. The carbonization process. Dried and degasified biomass is treated with.
My name is Sharifah Atika binti Muhammad Hanif. My metric number is S44181. Definition for hydrothermal carbonization. Hydrothermal carbonization is a structured process for the conversion of organic compounds to structured carbons. It can be used to make a wide variety of nanostructured carbons, simple production of brown coal substitute synthesis gas, liquid petroleum precursors, and humus from biomass with release of energy.
My name is Nahisa binti Hashim. My metric number is 42860. Today I would like to present about type of feedstocks. First is fruit waste. Fruit waste like orange peel and banana peel. Second is food waste. Food waste like household waste, restaurant waste. And then yang third is agriculture waste. Agriculture waste, like example of palm waste, palm kernel shell, corn straw, and bakers. Thank you.
Hi, my name is Siti Nofazani Abdurrahman S44092. Today I will present about the process of hydrothermal carbonization. Here we can see the general process of hydrothermal carbonization. At the feedstock, where we put the raw material and biomass. The feedstock later will be heated with water between 180 to 220 degrees Celsius with pressure range between 20 to 25 bar. The reaction will vary on 1 to 72 hours based on the biomass that we use. During this stage, there is two products that we produce. First is gas and second is celery. Okay, we may move to the celery. The celery is in the form of aqueous brown coal. Okay, because it has high content of water, so we need to remove the water content to get the final product. The slurry will be filtered. During the filtration process, a lot of water will be removed. During the process, the wastewater will be produced in a form of liquid. After the filtration is done, we can get our final product. Our final product is HTC coal. That's it for me.
Good day, my name is Aidara Fiza binti Khairuddin and my metric number is S44500. Okay, I would like to present about reaction mechanism involved. Lots of reaction could occur during the hydrothermal process at subcritical temperature, majority of them same with pyrolysis. The hydrothermal carbonization is mainly governed by hydrolysis, which break the ester and other bonds of cellulose at temperature 200 Celsius, hemicellulose at temperature 180 Celsius, and lignin at temperature 200 Celsius with addition of water. Okay, the mechanism for this process mainly entails decarboxylation, dehydration, polymerization, or aromatization. Hydroxyl groups are generally eliminated by dehydration. Carboxyl and carbonic groups are involved during decarboxylation. During the hydrothermal carbonization process, dehydration is more important mechanism than decarboxylation.
My name is Watan Adila binti Amin, S4189. I will present about type of products and their application. They have three type of products, which is solid carbonaceous product, water-soluble organic fraction, and gas fraction. Solid carbonaceous product, which is hydrochar. Hydrochar can be effectively used as fuel, replacing traditional fossil coal. Different feedstock, process conditions, and production technologies may result in different in hydrochar properties. Secondly, water-soluble organic fraction, partially formed from the solid dry biomass by chemical dehydration and from released biomass humidity. Then contain short chain carboxylic acids such as acetic and inorganic elements. Lastly, gas fraction, mainly carbon dioxide, CO2, composed by CO2 with trace of CO, CH4 and H2. The amount of carbon present into the gaseous phase is mainly due to decarboxylation.
Hello and good day everyone. My name is Nur Farah Nabila binti Roslan, metric number S44798. I will explain more about advantages and disadvantages of hydrothermal carbonization process. For the advantages, first, HTC material can be used for direct energy generation, for example, biocoal to decentralized energy application. Second, the technology can be also used to convert bio waste, which is from municipal stream, into useful carbon materials. Third, the resulting carbon material can be easily nanostructured or functionalized and used for important application in renewable energy, catalysis, CO2 capture or water purification. Next, the liquid phase contain important chemical which can be extracted and further applications such as converted in interesting biochemical and biofuel. Next, the water phase can be reused, which is this process can reduce the consumption of water. Next, the whole process is exothermic and therefore has a favorable energy balance. Next, wax process, which is biomass can be used without expensive. Next is this process accept numerous biomass type, such as agriculture waste, kitchen waste as well as food waste. Next is low impact technology with very low odor and noise emission. Next is simple, proven and robust, and multi-batch technology because low maintenance cost due to the proven and robust technical implementation. Next is simple mechanism, mechanical dewatering with filter presses to reach about 70% dry matter. content due to hydrophobic nature of biocoal. Next is excellent result for environmental impact assessment that have been proved by several studies before. HTC also allow for the currently most efficient phosphorus recovery. Last but not least, HTC is the only technology which allow for continuous co-incineration of sewage sludge to replace fossil coal and a highly phosphorus recovery at the same time pre-drying. Next, we move to the disadvantages of this process. First, an appropriate process management as well as problem in the collection, transportation and storage of accumulated biomass are unresolved. Second, this process also require energy which should be less than is released by hydrothermal carbonation. Third is a weakly pyrolyzed charcoal which still contain at least 4 per 5 of the calorific value of wood was propagated for thermal processes. Last, this process is a new technology, hence no commercially available HTC plant